All right, so we're looking at question, well, warm up number 70. So it's this one right here. And I am going to work this problem out. So, how many inches did this kid grow during this time? This guy started at 63 and 3/8 inches tall when he started in seventh grade. And then he finished in eighth grade. He was 65 inches tall, right? So, he's a little over 5'5". Um, so, what's the difference in growth, right? So, we know that's going to be subtraction. So it's going to be 65 and 1/4 minus 63 and 3/8. I remember doing this in fifth grade, and we did it this way. And actually, just goes 4 times 65 plus 1, 8 times 68, 8 times 64, and then plus 1. And then after that, you do this huge math, and everybody would freak out. And it should be a 63. I'm not going to do it that way. Our kids struggled with that in fifth, and he struggled with that from here on out. So I do know one thing. I have 65, and I'm going to subtract 63 from that. Right? If I had to set this up this way, 1, 2, 4, 5, 6. 1, 2, 3, 4, 5. That's 65. And then over here, one of these is a fourth. That guy is a fourth. Over here, I got 63. 1, 2, 3, 4, 5, 6. By the way, these are base 10 blocks, right? And a 3/8. So I've got one of my holes here. And 63 would be 1, 2, 3 holes right here, right? I have this. I got this guy would be cut into 8 parts, and then let's see, one more, and then it'd be 1, 2, 3 on this side. And I'm going to remove from here to kind of satisfy this problem here. Well, I can get rid of my 60s. So these guys are gone. These guys are gone. And I got 5 1s and 3 1s here that I can, remove. So all these 3 are going to be gone. So are these 3. What does it leave me with? 2. Okay, it's 65 minus 63 is 2 and 1/4 minus 3/8. That's it. That's all I got to worry about. And I'm golden. And notice that I got 2. Right, so I have 2 holes. And notice I'm using fraction circles. Hey, look, no area model. And a 4th. Right? I can use my markers and say, well, I don't need this part. These guys are out, right? They're out. They're not part of the solution, right? And so you shade them out, right? So I got 2 and 1/4. And I need to remove 3/8. Well, what does that look like? Well, let's draw it. I did it right here, right now. I need to remove 3/8. 1, 2, 3. That's what's got to come out. This is, I have to remove this much from here. And notice that if I look at this, I have more than a quarter here. This is bigger than this. So my answer is one of these guys. And this is not that much bigger than this. So I need to make these guys look the same. So I know then that I can redraw this guy. I mean, not so close. I can always move up. Or move down, sorry. I can redraw this guy and say, okay, well, let's make them 8s. 1, 2, 3, 4, 5, 6, 7. Did I miss something here? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there you go. And I know that 1/4 is this part right here, right? And I need to remove, let's see here, this 1/4 right here looks a lot like this 1/4 here, right? So I'm gonna remove this part. So this part's gone, and this part's gone. So he's gone over here, but I still got that 1/8 to remove. So I can come over here now, this hole, and remove one more 1/8, leaving me with 1, 2, 3, 4, 5, 6, 7. So 1 and 7/8 is left over. Ta-da! You're done. Help the kid out, guys. Draw draw the fraction bars, draw the fraction circles. That's one way to have done this problem, right? Once we kind of figure out that I'm moving back from 65 to 63, or find a difference between them, I can still utilize the number line. So you'll see one last look at the same problem. And one of the things that I also love is the number line, because I know I got 63 and what was it, 3/8? Yeah, 63 and 3/8 on one side. And over here was 65 and 1/4. Okay, so I'm gonna go, here's 65, here's 64, right? 63 and 3/8 is how far from 64? It's 5/8 from 64. 65 and 1/4 is 1/4 from 65. And the difference between 65 and 64 is only what? 1. That's it. So all I gotta add is 5/8 plus 1/4. What is 5/8 plus 1/4? And here you can play around with the common denominator question and so on. Amen. That's times 2 times 2. That's gonna give me that's 7/8. That's 7 on top, right? Because there's gonna be 2 8s and then the 8 on bottom, and there's my 7/8. They're in 7th grade. They should be able to handle something like that. If they need to draw it, have them draw it, right? Do another number line, do a fraction bar, fraction circle on adding that up. And if I had to do it on a number line, it would look something like this. And so we know then that I have the value 5/8. Here's 1. So I'll cut that guy into 8s. 1, 2, 3, 4, 5, 5/8, and I need to get to 1/4 more, right? A quarter more, and then have that conversation that these are my quarters. And so if I'm doing that, from 5/8 to a quarter is double to here, and that gets me to that 7/8, almost to 1, right? To 1 there. A lot of ways to do that part, but there's 2 ways, more than one way of just doing that old school, 4 times 65 at the 1. No, it's too much. So again, fraction bars, base and block representations, from base and blocks to fraction bars, to simplifying where the problem really looks. Number line. Try everything and anything you can with your kids, guys. It's going to help them out in the long run. They can draw from their toolbox to try to attack these problems in various methods, and that's what we want to do. We want to give them that opportunity to be successful. Please don't deny them of that.